Welcome to 10.5, the FOIL method of multiplying binomials. So this is a review of the last lesson, right? To multiply, in number one, we're multiplying a binomial times a trinomial. So we're going to multiply everything by x, and we get x times x squared, x cubed. Let's get rid of that stray mark. And x times 3x, 3x squared. And x times negative 5, negative 5x. Then we multiply everything by 2, and we get plus 2x squared plus 6x minus 10. And then we combine our like terms. We have x cubed, 3x squared plus 2x squared, 5x squared, negative 5x plus 6x plus x, and then minus 10. Right? When you multiply polynomials, you get another polynomial, right? Because multiplying, adding, and subtracting of polynomials is closed. All right, so here we have two binomials, and that is what we're focusing on today. You actually already know how to do today's lesson. We're just going to get faster. So I'm going to multiply the first two, right? 3x times x, that's what I did yesterday. 3x times x is 3x squared. Then I multiply 3x times 4, the outer two, and that gets 12x. Then I'm going to multiply negative 2 times x, right? And I'm going to call those the inner two. All right, negative 2 times x, negative 2x, and negative 2 times 4, negative 8. I'm going to call those the last two. And then we combine our like terms, which will end up in the center if we do it that way every time. And we get 3x squared plus 10x minus 8. And it turns out when you multiply binomials, what you end up doing is multiplying the first, the outer, the inner, the last. The FOIL method. And you end up with a trinomial the vast majority of the time, although there are special cases where you don't, and we'll go over those as well. So that's what we're doing, multiplying two binomials and getting a trinomial answer. All right, so later we're going to get to some special patterns, and here they are as a little preview, right? We're going to be multiplying binomials. So notice when you have the exact same thing twice, right, you could write that as x minus 7 squared, right? Then you get x squared minus 14x plus 49. Here you have x plus 7 squared. You get the exact same answer, but instead of minuses there, you still get pluses both times here. The only difference is right there, is where you get x squared minus 14x when they're both minus. You get x squared plus 14x when they're both plus. And the last one, though, is very different. Look at it, right? There's no middle term. What happened was you got x squared plus 0, x minus 49, and that went away. And that happens when you have plus and minus the exact same amount there. So we're going to see all that today. So FOIL, first, outer, inner, last. Right? So if I FOILed these, it would be a times c plus a times d plus b times c plus b times d. And it turns out these two end up being like terms, even though they don't look like that here. Okay? And we will see that. So first, x squared. Outer, 5x, x times 5. Inner, 2x. Last, 2 times 5, 10. You combine your like terms and you get your trinomial. First, 2x squared. Outer, 6x. Inner, 6x. Last, 18. Combine your like terms, 2x squared plus 12x plus 18. Now, today's lesson should not be hard because basically you learned this yesterday, but remember where we're headed. In the next unit, I'm going to give you these trinomials, and you're going to have to figure out what binomials we started with. You're going to have to work backwards. So you want to learn the pattern. So notice this is the easiest pattern. You get two pluses there, you're going to get two pluses there. You get two pluses there, you're going to get two pluses there. Okay. So now you have a plus and a minus. Let's see what happens there. First, x squared. Outer, negative x. Inner, plus 4x. Last, 4 times negative 1, negative 4. We combine our like terms here, so we get x squared plus 3x minus 4. So here, first, x squared, outer, 2x, inner, negative 3x, last, negative 6. So x squared, we combine those, minus x minus 6. Here, so now in both those on the top, we have one of each, a plus and a minus. And notice what happened. You will get a minus for the last one every time. You will, because if you have one, you're going to be multiplying a positive times a negative. So you're always going to get a minus as right in front of the last number. But the middle could be either, right? Because if you have more positive x's, you'll get a plus x in the middle. If you have more of the negative x's, you'll have a negative x in the middle, or a minus x. All right, so let's see what happens when they're both minus, right? When they were both plus, everything was plus. When they're both minus, is everything going to be minus? I'm not sure. Let's see. First, x times x, x squared. Outer, negative 5x. Inner, negative 3x. Negative 3 times negative plus 15. So no, everything is not going to be minus because you end up with a negative times a negative and you get a positive there. Let's see that again. So 3x times 2x, 6x squared, right? You get an x squared every time, but this time we have coefficients. 3x times y, 3xy, right? Negative y times 2x, that's negative 2xy. We put, alphabetical order. Negative y times y, negative y squared, right? Negative 1 times 1 is negative 1, so it's negative y squared. Combine your like terms in the middle, 6x squared plus xy minus y squared. Okay, so again, once this is one of each, like these other two, not like the one we just did, so you got a minus there, right? And then we had more positive xy, so you got a positive there. All right, so now we're going to do the same binomial twice, and the answer is a perfect square, right? If you have 7 times 7, the answer is 49, and 49 is a perfect square. If you have x times x, the answer is x squared, a perfect square. If you have a plus b times a plus b, you get that. A squared plus 2ab plus b squared, and that's a perfect squared trinomial. So let's see that. So my advice, write these out, and then you just do them like all the others. You get x squared plus 5x outer plus 5x inner plus 25. You get x squared plus 10x plus 25. All right, x plus y squared. So it would be x plus y times x plus y. You get x squared for the first. Outer is xy, x times y. Inner is y times x, also xy. Y times y, y squared. And you get x squared plus 2xy plus y squared, which is exactly the same as the example, except I used x and y instead of a and b. All right, so what's this? Well, that's x squared plus y squared times x squared plus y squared. So this one's a little more complicated. X squared times x squared, x to the fourth. X squared times y squared, x squared y squared. Y inner, y squared times x squared y squared again. Y squared times y squared, y to the fourth. Add your exponents. X to the fourth. Combine our like terms. There's 2 of these x squared y squareds plus y to the fourth. All right, so these answers are perfect squares, just like 1, 4, 9, 16, 25, 36, 49, and so on. Perfect squares, in this case, perfect square trinomials. And what's interesting, if you really want to take the time, take some numbers and for x and y and do the math. And guess what numbers you're going to get? You're going to get 1, 4, 16, 25, depending on what you put in there, you're going to get a perfect square number. Yes, there are perfect squares. Find the area of a square. All right, a square, all the sides are the same. And to find the area, you multiply 2 sides. So this is 9x minus 4y squared, or 9x minus 4y times 9x minus 4y. And you get 9 times 9 is 81x squared. 9x times negative 4y, negative 36xy. In the middle, you get negative 36xy, and then you get plus 16y squared. Negative 4 times negative 4y times negative 4y. So here you get 81x squared. 36 plus 36 is 72. So this is negative 72xy plus 16y squared. All right. And that is the area. If I now tell you x is 1 and y is 2, you could calculate the area there. Okay. All right, so that we just did a plus b squared, right? And that was a squared plus 2ab plus b squared. So look at the difference, right? The only difference is right there. Even the end is still plus b squared. So let's see that. This is x minus 5 times x minus 5. So it's x squared, outer is minus 5x, inner is minus 5x. Last is still positive 25 because two negatives make a positive when you multiply, and you get x squared minus 10x plus 25, right? So if I had changed that to plus, the only difference would be it would be plus 10x in the middle. Everything else would be the same. So this is 4x minus y times 4x minus y, which equals 16x squared minus 4xy minus another 4xy, negative y times 4x, plus y squared, and you get 16x squared minus 8xy plus y squared. Negative 4xy minus 4xy is negative 8xy. And here's that thing again. Standardized tests love this problem. That's why I keep putting it, because most teachers don't go over this one. X squared times x squared is x to the fourth. X squared times negative y squared is negative x squared y squared. Negative y squared times x squared is negative x squared y squared. Negative y squared times negative y squared positive y to the fourth. X to the fourth minus 2x squared y squared plus y to the fourth. All right, so now this is the tricky one that messes everyone up. This does not follow the same pattern as the ones we just did. The answer here is not a perfect square trinomial. In fact, it will be a binomial. Remember I said when you multiply binomials, like we're doing today, you almost always get a trinomial. This is the exception. Let's see it. X times x, x squared. X times negative 4, negative 4x. 4 times x plus 4x. 4 times negative 4, negative 16. So you add those together. Negative 4x plus 4x is 0, so you get x squared plus 0x minus 16, but you're not going to write it that way. You're going to write x squared minus 16. So let's do that again. So 3x times 3x, 9x squared. 3x times negative y, negative 3xy. Y times 3x, positive 3xy. Those are going to make 0, right? And y times negative y squared. And so we get negative x squared minus y squared. Did I say 9x squared minus y squared? I think I said that wrong. 9x squared minus y squared. All right, and there it is again, that same problem. X squared times x squared, x to the fourth. X squared times negative y squared, negative x squared, y squared. Y squared times x squared plus x squared, y squared. Y squared times negative y squared, negative y to the fourth. Those make 0, and you get x to the fourth minus y to the fourth. So what is the pattern here? Here you get a squared minus b squared, right? You get a binomial. The minus plus ab and minus ab cancel each other out. That's what you have each time here, right? A here was 3x, right? B was y. A here was x squared, and x squared squared is x to the fourth. It all follows that pattern. All right, I'm going to skip this one. All right, let's try this one. All right, so almost always we put x first, and then some cute test does this to you. Let's just see this. 3 times 6, 18. You still do it the same way. 3 times 5x, 15x. X times 6, 6x. X times 5x, 5x squared. 15x plus 6x, 21x. All right, now, the problem is this in descending order of the exponents of x? No. So if you were going to check an answer in the back of the book or on a multiple choice test, they would rearrange this descending order of the exponents of x probably, and that would be the answer. I would just do it in the exact order it is. Don't play with it, because when you start switching it at the beginning, you can mess it up. Just do it FOIL, first, outer, inner, last. See what you get. Look at your answer. Then if you need to rewrite it in descending order of the exponent of x, do that. So let's practice that again. 7 times 5. And this, because of minuses and negatives, that's why I highly recommend don't switch it around. Just leave it. 7 times 2x, 14x. Negative x times 5 minus 5x. Negative x times 2x. Negative 2x squared. So this is 9x. So we get, right, 35 plus 9x minus 2x squared. Rearranged is negative 2x squared plus 9x plus 35. There you go. All right, so let's practice. So I'm getting 21x squared plus 7x minus 9x minus 3. 21x squared minus 2x minus 3. This is x minus 11 times x minus 11 is x squared minus 11x minus 11x plus 121 equals x squared minus 22x plus 121. Please, the answer to that is a trinomial. Okay, people think they're doing the other one. It's going to be a trinomial. 4x times 4x, 16x squared, plus 44 times 12 is, right, 48. 48x minus 48x minus 144. This is where those add up to 0, right? You got one of each. And you get 16x squared minus 144. That is the one that becomes a binomial. Here it is backwards. 4 times 6 is 24. 4 times negative x and negative 4x. Negative 2x times 6, negative 12x. Negative 2x minus x plus 2x, yes? And so this is 24 minus 16x, negative 4x minus 12x, yes, and plus 2x squared. I left out the square. Don't do that on a test. I will take off, I think, all the points. All right, and there you go. All right, so this is, right, we did this the other day. Write it out. Remember, you cannot do distributive property until you write it out, because you only distribute over one of those, right? If you do 4 times 5 times 6, you do 4 times 5, 20, 20 times 6, right, 120. You don't start multiplying everything by 4. So you don't want to start multiplying everything by 3. You cannot do distributive property here at the beginning. That's for when it's not x squared. Now you can do distributive property if you want, and then you can multiply those. You get 3x squared. 3x times 5, 15x, plus another 15x in the middle. 15 times 5 is 75. So this is 3x squared plus 30x plus 75. Let me just do it another way just to show you, because this is going to be valuable later in the year. You can multiply the binomials first, and you would get, right, so it would be 3 times x squared plus 5x plus 5x plus 10x plus 25. Then you can do distributive property, and look, you get the exact same answer, 3x squared plus 30x plus 75, right, 25 times 3. All right, good luck with your homework.